Hello friends, today we're going to start out by looking at some vocabulary. Our first vocabulary is circle. Make sure after every word that you pause, write down the word, the definition, and draw out this example. A circle is just a set of all of the points that are the same distance from a given point called the center. So we have all of these points that are the same distance away from this middle center point. Make sure that you draw that circle and also label. The next one is the center. The center is a point in the exact middle of the circle. The circle is named by its center. So in this example, we have circle K. This circle is named by its center point, and that point is called K. The next word that we are going to go over is radius. Radius is just the distance from the center to the outer edge of a circle. So if you start in the center, draw a straight line out, and hit the edge, it needs to have the center as one end point and the edge of the circle as the other end point. That is our radius. Our next word that we're going over, and actually our final vocabulary word, is diameter. Diameter is the distance across the center of the circle. So we have one end point on one edge of the circle, we have to go through the center and to the other edge of the circle, and that is our diameter. We want to identify, yes or no, do these circles show a radius? So if we look at this first one, we look, is there an end point in the center? Yes. Is there an end point on the edge? Yes. Is that my whole radius? Yes. Coming here, we have our center point, our edge. This line is going straight between them. So yes, that is a radius. Now looking here, we have one end point right here, but the center is right here. So this one is a no because it's not hitting one end of the center point and one end on the edge of the circle. Looking here, we have, right here. We have our center point, awesome, but then it hits beyond the edge of the circle. So this one's going to be a no because we don't have that point ending right here. Okay, then center to the edge, yes. Center to the edge. This one doesn't work because we have this extra bit of line, so that one's a no. Center to the edge. We have this gap right here, so this one's a no. Center to the edge. This one is a no because we have way too much extra. This one would actually be a diameter. Okay? Going through, we want to identify the circles with a diameter. So remember, a diameter has two endpoints on the circle, and it goes through the center. So we have one endpoint on an edge, one endpoint on an edge, and it goes through the center. This one is a yes. One endpoint on this edge, we don't have another endpoint on this edge, so this one's going to be a no. Endpoint on this edge, endpoint on this edge, goes through the center. This one is a yes. Coming around here, we have an end point on the edge of the circle, end point on the edge of the circle, but it doesn't go through the center, so that one's a no. It doesn't quite work out for us. Coming down right here, end point on the edge, end point on the edge. We don't have a point in the center, and we actually don't have a straight line either. That's an angle. So that wouldn't work because of those two reasons. So this one is a no. endpoint right here, endpoint right here doesn't quite fit, so that is a no. This one doesn't work for the opposite reason. Instead of having a little gap, we have a little extra. So this is a no, that's not a diameter. Endpoint, endpoint, center, and this last one is a yes. So make sure you have all of those written down. We want to know, what is the relationship between the radius and the diameter? Well, if you notice, going from the center point to the edge, that's a radius. So if I go from the center point out to the edge, that's a radius. And going from the center point out to the edge, that's a radius. So what's the relationship between them? Well, the diameter is double the radius. So now we're wondering, can we write a formula for this? Something that's generalized so that no matter what our diameter or what our radius is, we can find the other one. Well, if we're looking for the diameter and we only know the radius, the diameter is double the radius. So that means we need to have 2 times whatever our radius is, gives us that diameter. If we're going the other way around though, and we know the diameter, and we're trying to figure out the radius, we would just do the inverse of that, which is multiplying it by 1/2, because the radius is half of the diameter. Now looking here, we want to find the lengths of the radius and diameter for each circle. So we have right here going from one endpoint to another edge, and we go through the center. That means that it's a diameter, so our diameter is 8 centimeters. Now we want to look, what is our radius? Well, let's use our formula. Radius equals 1/2 times the diameter. I'm going to plug in 8 for the diameter. 1/2 times 8 gives us our radius. 1/2 times 8 gives 4. So our radius is 4, and we need to remember our units, centimeters. Next, we need to look, do I have a diameter or a radius? Well, I'm going from a center point out to an edge, so this is the radius. The radius is 3 centimeters. Now I want to look for my diameter, so I'm going to use diameter equals 2 times the radius. My diameter equals 2 times this 3 centimeter radius. 2 times 3 is 6. So my diameter is 6 centimeters. Now we have a really interesting one here. I don't have a diameter or a radius across the middle of my circle. But if you notice, I have 13 centimeters labeled here. Well, if I come straight up this way, those should be the same measurement. Okay, so we have a diameter because it's going from one edge to the other edge and through the middle of the circle. Our diameter is 13 centimeters. Then we have radius equals 1/2 times diameter. The diameter is 13, so our radius is 6.5. So we have 6.5 centimeters for the measurement of our radius. Now, we know that this is 5 centimeters up here, which means that this is also 5 centimeters coming right here. So, that is my radius. And the diameter is 2 times the radius. So my diameter is going to be 2 times 5, which means it's 10. So my diameter is 10 centimeters. Make sure you pause and get that written down as you're going. Now, we have a couple of real-life problems. From the center to one of the cars on a Ferris wheel is 23 feet. We want to know how far across is the Ferris wheel. So if we start at the center and we're going out to one of the cars, that is a radius, and that is my 23 feet. Okay? So if my radius is 23 feet, and I want to figure out how far across is the Ferris wheel, well, going all the way across, that's a diameter, right? So let's use our formula. Diameter equals 2 times the radius. We know that the radius is 23 feet, so I can do 2 times 23, and my diameter is 46 feet. That means that the Ferris wheel is 46 feet across. Now looking at the bicycle wheel, we know it's 28 inches all the way across. We want to know how long is one of the spokes. The spokes are like this part coming up to the center. So this means that we have the diameter, we have all the way across, and we want to figure out half of the diameter, which is the radius. So radius is 1/2 times the diameter. Radius is 1/2 times this 28 inches, which means that our radius is 14 inches. So from the length of one of the spokes is 14 inches. Now we have something a little bit tricky. We're going to figure out how to plug in what we do know and solve for what we don't. We want to know what is the value of x. So if I look, I have a radius and I have a diameter. I'm trying to get it so that the one that has my variable is on its own side without anything else. So I'm going to take x plus 7 and put it on one side of the equal sign, because I want to eventually get this x all by itself. Well, x plus 7 is all the way across our circle, so that's a diameter. I want to use the formula for finding the diameter. That's 2 times the radius. And the radius is 22 feet. That's this length right here. So I have x plus 7 equals 44, because 2 times 22 is 44. Then I want to subtract 7 from both sides, and x equals 37. We're going to try another one of those out. We want to solve for y. In this case, y is on our radius line. So we want to use the formula where we're solving for the radius so that it's easier to get y all by itself. So I'm going to put 5y minus 2 on one side of the equal sign. That's my radius. Now I have to move over to the other side of the equal sign. I have 1/2 times the diameter. The diameter is 36. 1/2 times 36 is 18. We're going to bring down our 5y minus 2. Then I'm going to add 2 to both sides to get that to cancel out. I have 5y equals 20. Then when I divide by 5 on both sides, I get y all by itself, and y equals 4. And that's how we solve that type of problem. Okay? The donut's radius is 2 inches. If the diameter measures 4b minus 16 inches, we want to know what is the value for b. So we're going all the way across this donut. 4b minus 16 inches. Okay? Then we know that our radius, so from that center out, is 2 inches. I want to figure out what is the value for b. So I'm going to put 4b minus 16 on one side of the equal sign. I know that that's a diameter, so it has to be 2 times the radius. Well, the radius is 2. So I'm going to have 4b minus 16 equals 4. I'm going to add 16 to both sides. 4b is equal to 20. Divide by 4 on both sides to finish solving, and b equals 5. And that is how you solve that. Remember to continuously pause the video, take notes, go back and re-watch things if they don't make sense, and email your teachers if you need any help. Good luck, my friends, and have a great day.